Hello friends, in the previous lectures we have talked about the paleogeography of the Paleogene times, and in this lecture we will be talking about the geological history of the Neogene time. The geological history of Indian subcontinent during Neogene shows firstly a progressive continental trend in sedimentation. That means the sedimentation progressed towards more in the continents with variable climates, with southwards and eastwards shift of the climatic zones, and a remarkable stability in marine and non-marine sedimentary regimes, with Himalayas representing main source of sediments for North India from Miocene onwards. Coal is less frequent in Neogene, and the time shows a widespread distribution of mammalian fauna, constituting the main criteria for stratigraphic correlation of non-marine deposits. Some major events of the Neogene periods in India can be summarized as starting from the early Miocene. Both marine and non-marine conditions prevailed in eastern and western sectors of the continent, with non-marine deposits being confined to northern sectors only. The Sindhu and Bangla seas were shrinking southwards along both the flanks. The plants such as palm and pinus were widely distributed. That palm is also found in the intertrappean beds of the central India of the same age. The gudge beds of Sindh Baluchistan and their equivalents to the Indian subcontinent represent deposits which were essentially deposited in a transgressing sea, not only across the axis of Sindhu Sea, but intermittently across the coastal peninsular region of India and Sri Lanka. The close of Gudge period is marked by increase in non-marine conditions of deposition. The end of early Miocene epoch is therefore similar to the end of early Eocene, as both periods marked phases of increasing continentality. Pre-Shivalic lower Miocene vertebrates have a widespread distribution across the Indian subcontinent, with 101 vertebrate species reported so far. The mammals are represented by terrestrial as well as marine forms and reflect oscillatory marine and non-marine sedimentation. Oscillatory means cyclic, which is a constant feature of the lower Miocene coastal deposition. Terrestrial mammals are known from Bagti Hills and Fateh Jung in Pakistan, in western Sindh, Ladakh and Udhampur of Jammu and Kashmir in western sectors, and from Garo Hills in Assam. Marine mammals are recorded from Kutch, Peram Island and Sri Lanka. The coastal tertiary of peninsular India, both along western and eastern coast, are characterized by similar assemblages of sharks, rays, teleosts, turtles, crocodiles, sirenians and cetaceans. The presence of 30 to 40% species of Miocene marine vertebrates and mollusks in the present Indian Ocean shows the existence of stable environment. It is inferred that except for some minor eustatic transgressive regressive phases, paleoecology of the peninsular shield shorelines has little changed since the early Miocene. The marine deposits of both western and eastern coast of the peninsula are correlated by the species like Myogypsian tanny, Myogypsina globulina, Archaeus, Malabaricus, etc. The widespread occurrence of these species suggests a contemporaneity of the faunas. The deposition of lower Miocene rocks in these areas took place in a transgressive sea in a tranquil condition. Tranquil means agitated conditions, and the depositional environment was epineritic to neritic. This indicates that the lower Miocene sea had penetrated quite far inland. The migration of fruits and seeds of the Dipterocarpaceae shows that land connection was established between eastern India and Burma and Malaya during the Miocene. In Assam, the Oligocene epoch was marked by a gentle differential movement, as a result of which the Shillong Plateau and Mikir Hills were elevated to a higher level. The Bengal Sea receded southwards to Arakan. These streams, comprising mainly Brahmaputra and its tributaries, became active and reached the early Miocene coastline at about 26 degrees northern latitude. Further eastwards, the Proto-Irrawaddy delta was accumulating sediments at about 24° north latitude. Sri Lanka was first separated from the Indian mainland during early Miocene, when a wide arm of tertiary sea extended across the southern ocean of peninsula, as evidenced by the presence of marine deposits in northern and northwestern part of the Sri Lanka, including Jaffna and northern peninsula. The sedimentary regime in various parts of the subcontinent had been discussed by many workers. It appears that these were characterized by different environmental setting. In the northern sector, Murree, Dharamshala and Kasauli, these beds show effects of Himalayan uplift. The early Miocene marks the first sedimentary contribution from the rising Himalayas. In the Sindh, Balochistan and Kutch areas of the subcontinent, a gradual transition from marine to non-marine conditions is noticed from Aquitanian to Burdigalian. In Kaveri Basin, there was a transition from marine to continental basins. As a result, a continental facies developed in western part, while the marine environment continued in the eastern part as well as in the offshore areas. In Assam, Bangladesh region, the major Himalayan uplift is marked by the presence of a regional unconformity at the Oligocene-Miocene boundary. The lower Miocene Surma group of Assam indicates a fluvio-deltaic, brackish and marine succession from north-south. In West Bengal, the lower Miocene sediments were deposited in an open marine environment. Mammalian fauna were widely distributed, including Africa and South Asian remnants were well represented. Kutch and Kathiawar were the places where both marine and non-marine mammals lived together. Kasauli and Murree formations belonging to the age Aquitanian Burdigalian received much of their detritus from the Himalayas. Coal and lignite development was restricted to the western, eastern and southeastern sectors of the subcontinent. This was early Miocene. Now, let us talk about mid to late Miocene. The middle Miocene was a crucial time in the history of the subcontinent, and its far-reaching effects extending from northern Himalayas to the Sri Lanka. In the Himalayas, the mid-Miocene uplift was one of the strongest orogenic impulses, and it initiated mainly southward dispersal of the coarse clastic sand and mud, characterizing older formations of the Shivalik group. The initiation of the continental condition from mid-Miocene to the present is mainly because of the continuously rising Himalayas with simultaneously sinking foredip of the Indo-Gangetic basin. The sedimentary regime of this basin even today does not appear to be different from the mid-Miocene times. The common occurrence of Dipterocarpaceae throughout the subcontinent suggests that during this period the climate was tropical, humid, with plenty of the rainfall over large part of the subcontinent. A higher percentage of angiosperms, mostly palm and grasses, suggests tropical coastal plain vegetation, and it has been inferred that a mean annual temperature between 21 degrees to 25 degrees and annual rainfall of about 125 centimeters may have prevailed in the subcontinent. In the middle and late Miocene, coal and lignite development was restricted to eastern, southern and southeastern sectors corresponding to the areas having warm, humid and tropical climate. Middle and upper Miocene mammals once again have a widespread distribution across the Indian subcontinent. Mammals have been reported from western Sindhu, Kutch and in western sectors throughout the Sivaliks, Salt Range, Kargil in North Himalayan belt and lastly from the Burma in the eastern sector. Lower Shivalik faunas were quite similar to Miocene fauna, known from the Palearctic localities because it contains various species of Dryopithecus, primitive carnivores, felids, mastodons and anthracotheres. The majority of the Asian Dryopithecus are reported from the Shivalik hills in India and Salt region in Pakistan. Dryopithecus have also been reported from the Kamlial, Chinji and Nagri stage. During the mid and late Miocene, Sri Lanka was again connected to the Indian mainland. The presence of some elements in the type Shivalik fauna in Sri Lanka and South India shows that minor marine oscillations did not disturb the migratory land route between Indian mainland and the sea. In the eastern sector of the Indian subcontinent, that is Bay of Bengal, deposition in the form of submarine fan by turbidity current was initiated by the easterly flowing rivers since the mid-Miocene times. The entire Bengal basin became a more marine in general southeasterly direction with a basinward decrease in sand content in various sedimentary formations. The source area for the Bengal basin was towards the west and north, that is Chota Nagpur and Shillong Plateau. During mid-Miocene, Chang Plateau of Burma experienced a marine transpiration. However, in northern Burma, mainly fluviatile conditions prevail, while further southwards marine conditions were present. The depositional history of Bengal and Assam Arakan Basin was essentially similar after the Paleogene. The value of Hipparian datum in determining the boundary between early and mid-Shivalik has been a matter of interest. According to the earlier studies in southern Potwar, the lowest occurrence of this equid has been placed above the base of the Nagri stage. The biostratigraphic significance of Hipparian datum has been dealt with by some workers. However, the contemporaneity of the first appearance of Shivalik Cormohipparian or Hipparian with those of the Western Old World and New World still needs further elaboration. Polyphyletic lineages were involved in the initial Hipparian radiation both in the Old and the New World. Then comes a very important aspect to discuss, that is the depositional environment. The Tipam Dupletia or Dehing Namsang succession spanning the time from middle Miocene to the early Pleistocene is the coeval to the lower middle upper Shivaliks. The Dupitilla of the foothills of Shillong Massif comprises an upward fining succession of trough cross laminated sandstone, ripple cross laminated sandstone, finely laminated mudstone and with ripple marks and massive mudstones characterized by rootlets. Here I would like to say that what is the difference between laminated mudstone and massive mudstone? Whenever the sedimentation rate is fast, then the layers do not get time to form. Then the rock which is deposited will be massive. When sedimentation happens in a very slow pace, then you get one layer and then another layer and then another layer. So, layered sedimentation, to form the layering you need slow sedimentation. So, wherever the term massive mudstone or massive sandstone comes into being, that reflects a fast sedimentation, and wherever you get fine laminations, very well developed laminations, that is probably due to the slow rate of sedimentation. It represents a deposition of meandering river, the channel of which was 5 to 30 meters deep. In a part, it is an alluvial fan that had channel directed towards south-southeast, south and south-southwest. That means a broadly southwards flowing system, and their depth varying from 87 to 185 meters. The Tipam formation in the Chittagong Hills in Bangladesh exhibits sedimentary features indicating deposition of the sediments in tidal marsh. In the Lalmai Hills of Chittagong in Bangladesh, the Dupitila formation comprises Piedmont alluvial deposits. In its lower part, the sedimentary features of the deposits indicates southwestern paleoflow of braided rivers, while the middle and upper parts are made up of the deposits of the estuarine tidal flat. Warm and humid climate conditions prevailed during the Shivalik times. In the Myo-Pliocene Tipam formation in Mizoram, a petrified forest has been identified at Zuam and Buchang, indicating presence of the plant precursors to the 645 modern Marginifera terminalia, Shoria and Dalbergia. The plant fossils indicate warm, humid climate with heavy rainfalls during the Tipam time. The floodplains were clothed with thick rainforests, particularly in the early Shivalik times. This is evident from plant fossils. With abundance of food available from forests and water being a plenty in the land of rivers, lakes and swamps, a rich and varied life grew and flourished dramatically. In these streams lived reptiles, including crocodiles and turtles, and the swamps were populated by rhinos and hippos. In the forest lived mammals such as tigers, elephants, buffaloes, cows, deers, goats, and tree-climbing primates. Attracted by the abundance of food, water, and living places, herd after herd of the quadrupeds came to this land of plenty from the as far as northern Eurasia, Africa, and North America. Then comes the climate change and the intensification of monsoon. The fast rising Himadri must have become a loftier barrier, high enough to cause disruption in the west to east flow of the air currents, bringing the low pressure areas southwards over northern India. The low pressure area attracted moist summer winds from the Indian Ocean and caused spells of heavy rainfall. The sudden appearance of endemic and native upwelling species in the Indian Ocean or planktonic assemblages between 8.5 and 7.5 million years indicates activation of upwelling currents, which must have been set in motion at 8 million years by the southwestern monsoon winds. The monsoon climates characterized by alternating long dry and short wet seasons. It was initiated in the late Miocene when the Himalaya attained its crucial height. The carbon-13 values of the soil carbonate in the Shivalik succession imply that 10.5 to 6 million years ago, the floodplain was covered by C3 type of vegetation, and in the period between 6 to 1.8 million years by the C4 type of vegetation appeared. The oxygen 18 versus oxygen 16 isotopic ratios of the soil forming clays within shivalic sedimentary succession indicates intensification of the rainfall at 11, 6 and 3 million years. This deduction is in agreement with the finding of a study of carbonates in the soil forming clays in a 54-kilometer stretch of the Ramnagar areas in southwestern Kumaon, which showed that the oxygen 16 isotopic value varying from minus 122 percentage to minus 5.9 percentage in the older part increased to nearly plus 2% in the younger, implying increase in the rainfall at 10, 5 and 1.8 million years. Increased rainfall caused acceleration of erosion. There was nearly sudden 2.5-fold increase of sediment accumulation in the Port-Var sub-basin at about 11 million years and at about 10 million years in the Nepalese Aruncola and 9 million years in the Tinaucola. This event implies that the Greater Himalayas or Himadri suddenly became a higher mountain and exposed to brisk erosion. The first appearance of kyanite in the heavy mineral assemblage along with the sand-sized gneissic fragments in the middle Shivalik at about 9.2 million years. It corroborates the postulation that Himadri rose up as high as barrier of about 9 to 10 million years ago. Neodymium, strontium and oxygen isotopic compositional similarities demonstrate derivation of the Indian Ocean sediments from the Himalayan crystalline terrains. Abundance of calcic amphiboles at 10.9 million years and of other heavy minerals between 10.9 and 7.5 million years in the Bengal fan deposits in the Bay of Bengal, coupled with the manifold increase in the sediment influx into the northern Indian Ocean, corroborates the deduction that Himadri was uplifted rapidly in the late Miocene times. The intensity of sedimentation and flux into the ocean is further borne out of the abrupt increase of the land-derived organic matter from 0.5 to 2% in Arabic Sea at about 9 million years from now. The organic matter was transported with the clay material derived from the denudation of the vegetation cover in the Lesser Himalaya that was exposed to denudation in the late Miocene. Not only the organic matter, but also the phosphorus content and the cerium silicon ratio in opaline silica of diatoms and the strontium ratio in the sea water increased perceptibly during this time. So, we have seen a lot of changes in the Indian subcontinent during the Neogene times, starting from the intensification of monsoon to the coal formation processes and diversification of the mammalian fauna. We will be discussing about the paleogeography of the other geological times in the coming lectures. Till then, thank you very much.